I gave this talk last week actually at Randa.js, and it was originally designed to be kind of more focused on kind of people interested in Node, in JavaScript. So I've kind of taken some stuff out. I've brought some stuff in that I hope's helpful.
Have you done it down for an optional?
I wasn't going to say that, but but yeah. So
JavaScript.
Just hopefully I'll be able to share a couple of things, well, several things that we've learned through building Node.js Microservices, and the journey that we've been on. Things are really taking off here since a year ago. Things are really starting to sort of change, and it's been a real journey, which I think we've got a long way to go, but hopefully we'll share some interesting things. So first of all, microservices aren't easy. Sometimes people think, don't they, in themselves, that if I only switch to microservices, my life is going to be better. You know, everything's just going to be suddenly better. Get rid of the monolith, everything's suddenly a lot better. And what you find yourself facing is the fact that you've got to handle distributed logging. What happens if something fails downstream, transaction or whatever? You've got different development teams trying to share different microservices, duplicating lots of code. How do you handle all that? So it's actually quite a difficult thing, and it raises a number of different costly things you need to introduce into your pipeline. And the thing I'm trying to get at here is that not all monoliths are bad. If they're well-tested monoliths, they can be a good thing. But microservices are certainly not easy. Just a little bit about me. So I spent about 7 or 8 years as a Java dev. Worked at a few companies and really enjoyed doing Java, but found myself increasingly doing more JavaScript. And it was at First Utility that I got the sort of privilege of working on the mobile app there. And then I managed to get their first Node.js Microservices services into production. With the help of Richard, actually, wherever he is, what I found when I was doing this is they really sped up our development time, and they were really easy to deploy. And the big plus I found with them was that we were able to hire one team. It opened up, wow, you can actually have one guy who can do the front end, who doesn't have to wait for the back-end developer to expose the fields he needs on the API. He can just do that. You don't have to wait for your Java developer to do it, or your Scala or whatever. One team, and I just found it really satisfying because most of the front-end developers there were really frustrated because they couldn't change the APIs because they had to know Java, you know. So that was really great. And so when I joined Wealth Wizards a year ago, we had this kind of situation. It wasn't all bad. We had a product. You know, we got to market. It enabled us to get to market, and there were many positives about it. But the real problem with it was that we kind of inverted the test triangle, and so we had all these tests, and if you start writing code in our kind of old monolith, what you find very easily is you almost have to deploy it all somewhere to test whether something actually works. You don't get very quick feedback. And we also had really a lot of issues with our front ends and not a lot of tests going on at the unit level. And so where we are today is that we've moved everything to AWS. We've adopted kind of Node on the back end. We're still supporting some legacy PHP, and we're using React and Redux on the front end. And as Sam will highlight a bit later, we've adopted a lot of automation, which has really helped us. And just to highlight again, you know, we've hired people who can do and are learning to do both the front and the back end, which is really enjoyable as a developer. So what I'm going to cover this evening, just a few pointers. Not going to go into a lot in detail, but these are the sort of things that I hope to touch on and hopefully offend you. So I think the first thing I found was that you really have to decide on your core libraries when you're doing microservices, because what you don't want is that developers going off on their own, and someone, let's say, I don't know, using Express and someone using Koa, and you might say, well, if you're using Docker and you're using everything's hidden behind a microservice, then surely you've got total freedom and flexibility in doing that. The problem with that is that if everyone does their own thing, then it's very difficult for developers to just context switch and then pick up a new microservice and start working with. So we've taken the decision that we're going to use Node unless we really need to use something else. And we've gone along the lines of using these main core libraries, which allow us to work with an HTTP server, do kind of functional styling kind of programming, work with a database, and so on and so forth. So what we found very quickly is we needed to be able to share code across microservices. So we decided as a team to set up a Nexus repo, and this is how you do that for Node. So you create this little npm.rc file, either on your computer or within the microservice itself, and you have these little credentials that tell it where to pull down the dependencies. And this allows us basically to author packages, author dependencies, and publish them to Nexus, and then they can be shared between microservices. And you include this little snippet in your package JSON file, and this allows you to publish stuff up to Nexus. But the thing is, what I found, though, is that don't go too far down the lines with that sort of mentality, because if you do, what you'll soon find yourself doing is you've moved away from your monolith, where you've got all the problems that comes with that. And then you've got this situation where I want to bump a certain shared library, and then you find that actually I really, or there's a bug in that, I need to also deploy at the same time all these 5 other microservices. And so the problem you've then got is that every release you do is a release of 5, 10, 15 microservices rather than just one. So the best thing to do in that situation is to try and put shared code in a shared service rather than having lots of shared microservices sharing business logic in an NPM repository or a Java jar file or whatever, that kind of thing, whatever you're using. So we decided to share a lot of logging. We've been trying to tidy this up recently, actually. And you'll notice Express has this idea of middleware, which you can kind of register on your HTTP server. And what I would say about logging is that if you've got the money, use Trace or New Relic. Trace is especially good for Node because it instruments into the Node core library, so things like the HTTP library and Mongo's library. And what you can see in Trace's dashboard is with one line of code, it will show you very quickly the queries that are running very slowly. So that's really helpful without having to doing lots of profiling. That was really helpful for us, although we haven't currently got the money to pay for it. But I would recommend, if you've got the cash, go for one of those 2 scenarios. And Trace also, very quickly, with one line of code, it starts to capture where you're making requests and what your databases you're communicating with, and you get a kind of map like this, which I'm sure there are other tools to do to create you, but I found it quite nice when I was experimenting with Trace. So just one line in your microservice, it just picks up the fact that you're making calls to service A, B, and C, and talking to this database, so on, and then it just shows you a nice map and highlights the problems in your system. So doing it yourself, this is kind of how we've done it, so a bit deep down the code, but essentially we've got this idea of creating a correlation ID and sending that on to services that we call. And the problem with that is it gets a bit painful because what you find in Node, because it's single-threaded, is you start having to pass the correlation ID to the function where you make the call to whatever service that you're making. So you can't do anything clever like you can with Java or C# or so on, whereas where you can bind it to the thread, because it's single-threaded, you've got to pass it around. So that's a slight negative. Although I have seen that Trace have got around that. I'm looking in their source code, not sure how they've done it, but they've done something clever and I can't work it out. We also, Graham suggested this recently, it was an article that he shared around, which was instead of these kind of classical logging, what we were finding was using these things, even myself, I was just going log.error and I was just spitting all sorts of stuff out into the error logs. And not really thinking about it, not really thinking about, what does that mean? And I'd always hear like Richard there saying, why is this like stuff being logged as error? We need to get that changed. So this article really was really helpful because it made us change our kind of interface for all our logging, so that now, when you're a developer, you're actually thinking, aren't you? When you're writing log.wake me up in the middle of the night, it makes you think, doesn't you? Why am I logging this? Do I really want to be woken up? Maybe you're awake already and suffer from insomnia, but I don't know. That's the sort of that's made me think. Anyways, that's been really helpful. And we developed these middleware packages as well, which have been useful. And these allow us to very quickly, when the app starts up, register what we want to ping to check that things are alive. And that's really helpful, isn't it, from a DevOps point of view? You want to build a microservice seeing what's alive. So we've got these health endpoints, and these give us, you hit /health on our microservice, and you get this information about service A is healthy and so on. And we've got a /ping, which tells us the version, because you kind of need to know what version is deployed in what environment. And we built this kind of dashboard that shows us in our different environments what versions are running. And so over the last year, we've built about 50 microservices. Is that roughly true? About 50 or so now in a year. So you imagine if you don't get that sharing of code right, you get the logging wrong, and you get the monitoring wrong. If you think if we grow in 4 years, what that's going to be like 400 or 500 microservices, maybe, who knows? But it could be. So it's a big problem in it. That's why you need a mono repo. But there you go. Another thing, a bit deep down the code, you want consistent API responses for validation. So we use this really good library. Again, if you're that way inclined and use JavaScript, then Joy's really good for that. It allows you just to quickly basically specify that in the body of a request, these fields should be present. And it's really helpful because it gives you a consistent API response. There's a nice library that we've kind of before it actually came out, I think we created something similar. So another thing that we've done that's helped us is we've kind of abandoned doing OO as a programming style. If you're familiar with that, I don't know, but we've using this thing called Randa, and I'd recommend that as something to look into. And it gives you a lot of, I think again it does spill over into the sort of DevOps world, doesn't it? Because when you're trying to hunt down bugs, often a lot of bugs I think in production are caused by side effects to code that's being written and things being mutated and unintentional issues. You spend hours trying to hunt down what's the problem. And what Randa does is it gives you the ability to write functional code, and you've probably heard a lot of the benefits of that in the past. But I mean, a lot of us have written stuff like this before. Can anyone see the problem in this code? Or anyone see any issues with what I'm doing?
Mutation. It's very codey.
Mark, yeah. Maybe very. Yeah. It's
lots of equal signs in it somewhere.
Yeah. So,
what language is this?
So I mean, in this particular bit of code, we're mutating the incomes that we're passing in. So JavaScript has really enabled us to sort of, even in out-of-box JavaScript, you can shrink that down to get rid of that mutation. And then with Randa, you can do some nice stuff where you create these composable functions and you apply them bottom to top. And that does the same thing as I've just shown. So one I particularly like is when I'm working with bits of data. And I would say as well, one of the things that I was always having to do in my previous job is I was always writing a lot of scripts and scripts to interface with Apple to send push notifications, for example. And the power of Node I found in that, and for my testing, was that I could write scripts really quickly. And I'm not an ops person, but I imagine that if you were having to write scripts a lot, I just feel that Node is just so superior than any other language for doing things quickly. Personally, that's because I know. And the number of libraries there are and the development community just far out exceeds anything else. So I would say that it's great for that. One of the great ones I like to sort of often manipulate an array into like an object where which is keyed by certain things. And kind of in plain JavaScript, you can do it like this, but in Randa, you can do it in one line. So it's just an illustration of how quickly you can do stuff with a functional language and style. And this is, again, we've got this little thing in the office, which is, we worship the Randa almost. Daily Randa you hear quite a lot. This is perhaps more interesting maybe for people. I mean, everyone raves on about 12-factor apps and how they're great, aren't they? And you've got all these environment variables, and you can get rid of these kind of Jindy settings and properties config and all this stuff, and you've got environment variables. But one of the things I found really quickly was that I wouldn't know when my app started up. Have I specified everything? I get instant feedback. And what we found was this library called Envalid, which is really helpful because you instantiate it at the beginning of your app when it starts up, and it will tell you straight away what you're missing. So this is just a sample thing you get in the logs, and it just kills your app straight away. And it kills it based on the definition that I provided here. So I'm saying here it must have a port, etc., etc. And I'm actually telling it what the data type is as well, because I remember when I first started doing Node, I actually wrote code to parse stuff, parse a 0 and a 1 to a Boolean or a string, whatever, you know what I mean? And you get into issues there. So I found Envalid really helpful. But I mean, ops guys are always barking on about, why is this broken? And, it's not tested and so on. So we've tried to put the test pyramid really the right way around, and we've kind of separated out the types of tests. So stuff where we're testing in an isolated bit of code known as a unit test. We've separated out the tests that we do from our sort of API within the pipeline tests where we mock out calls to other services. We call them component or integration tests. And this is kind of really illustrated by the Jenkins pipeline that we have. where we kind of have these different stages, and they're consistent across different microservices. And I think that's, again, that's all part of not context switching. Developers here, I feel, when they work on the different microservices, know that, you know, that's the stages that we adhere to. And this is all kind of done, I've lost my thing. Before I get on to where I was going to get onto, which is another thing we're looking at the moment, is actually contract testing. Something that we've been looking at in our team at the moment. And one of the challenges you get with microservices, coming back to my original gambit, is that, you know, you've got these services and they could be being used by lots of different people, and the contracts could be changing all the time. And there's this really useful tool called Pact that we've got some kind of working prototypes now that we're hoping to sort of incorporate, where you essentially you define what you expect your provider to do. And you create these known as contracts, and then you publish those contracts to what's known as a broker. And then every time the provider, any changes are made, it runs through the contracts to check that it still fulfills the contracts that it's promised to adhere to. So you define the expectations, and then you verify the expectations on the provider. This is something we're working on. I'd encourage people to look into if they're interested in microservices. Something that I believe Dave set up for us, or maybe even some before, which was using Sonar, and we include this little bit of config in our projects, and also in our Jenkins file, which is a Groovy DSL, allows us to run this command I dug out, and we're able to essentially statically analyze our code. And this is just an illustration of some of the microservices that we've got. And if you drill down, you get information about vulnerabilities and code smells and so on. And of course, I picked a nice example of something I wrote. 100%. 4 lines of code. No vulnerabilities.
God, what reset
empty file version 34.
Well, you can change an empty file.
Yeah, I think we ran this against our old engine, PHP legacy code, or something like 9,000 code smells. So there you go. So it does work. But I mean, so yeah, Sonar's really good, and we've integrated it into our Bitbucket in the builds in Jenkins, and it alerts and notifies our pull requests in Bitbucket as well. So again, developers get feedback straight away. And again, just one of the last couple of points really is, I touched on it earlier, which is avoiding kind of pipeline diversity. And you kind of want your pipelines all to look similar. And what we've done is in our Jenkins file, we've kind of followed these kind of common stages within our Groovy DSL. That these stages, if you like, if you're not familiar with Jenkins, is that in the Groovy, by declaring a stage, you essentially in the UI, you end up with these different columns. And what we've done is we've actually abstracted as much of the logic away from the Jenkins file as possible. And the reason for that is because if we switch to another language, we don't want these Jenkins files to be, you know, Node-centric or Java-centric or whatever. We want to push down the logic into the microservices and have this common contract, if you like, or layer, abstraction layer, and that is our make file. So make install, or I don't know, make unit test, that might run some, who knows in the future, C++ tests, you know what I mean? But all we'd have to do is change the make file in the microservice. We wouldn't have to change the Jenkins file, and that's the kind of thing that we try to do, and that's an illustration of some things. This touches on a little thing that I would say as well, is that, again, one of the things we had here in the past is we had loads of snowflakes, loads of things sort of deployed and installed on servers that no one knew that they were there, what version they were. And so when that server went down and we tried to deploy it, no one knew the versions, and so nothing ran. So again, what we try to do is in our pipeline is run all the stages inside a Docker container. So again, that sort of is really helpful because it avoids that problem. And what we've done is we've used Docker Compose to do that, which again has been really helpful. And recently we've kind of created our own. We had there was a security vulnerability in Node, and so we had to upgrade all our microservices. So now we've kind of created a base image that you'll see there. And again, we've got these common targets in our Docker Compose file that, yes, they delegate down to to run these different targets in our package JSON file. But the really good thing about them is that They're common, and they run inside a Docker container. So they're to guarantee you can be sure that what you're running is the same version as what we're running in production, as much as possible anyway. So I found Docker Compose and all those things I've mentioned really helpful over the last year. We've still got a long way to go, but I think that we've made massive improvements as a team. And we're also hiring. We've got a couple of vacancies still available in the team. So if you're interested, do let me know. Docker Compose also allows you to kind of do a real nice test as well with a database. You can spin up Mongo or Postgres, and I'm sure you're familiar with that. But that's been really helpful in our integration type component tests that we write. Any questions, just to finish?
What would you say the single most important thing is in moving services?
That's difficult. I think it's in a sense it's the same. It's a kind of religious choice, microservices or a monolith, and I think the same thing applies in both, which is to test your code, because I think that is the most important thing for me, because if you don't, then you're in the same problems. You're in actually more hell in microservices. So I would say that's probably the biggest thing.
Yeah. So your trace thing that you introduced, is that open source?
No.
It's something you have to pay for.
Yeah.
Does that run inside the container, or is that?
Yeah, it does.
It does the instrumentation. So can you then expose like an endpoint from that? Because it had like requests per minute on your diagram, and use that to inform your sort of auto-scaling decisions.
There's a couple of options. I mean, one thing we played around with is similar plugins for Node is like Prometheus. There's a similar thing, which
it's scraping an endpoint.
Yeah, an endpoint.
Health and metrics and other information.
Sure.
There's probably a way to cobble it through trace, but I suspect you'd have to talk to. So trace will emit metrics to a central aggregator like New Relic does. So you'd probably have to query their API to expose that.
Okay.
But it's probably quite a roundabout way of doing it.
Possibly.
You're probably better off doing it through your load balance metrics on ELB, which might be much more readily able to talk to.
Yeah, it's more about actually
scaling
finding out, making the scaling decisions before the service falls on its arse.
You're using Docker
Rather than
afterwards at some point.
Shh. Another thing, with the later stages of your presentation, with the sort of the evolution of the build pipeline, we looked at sort of multi-stage builds and how to get sort of everything running in Docker from a everything's in the code base. Jenkins doesn't really do very much at all anymore.
We kind of, yes, I guess. I mean,
and it slims down your runtime image as well. You've got the concept of build time dependencies and runtime dependencies, haven't you?
yeah, I mean, a lot of it, when you say not a lot running in Jenkins, I mean, what do you mean exactly?
So if you do, you can create a Docker file that builds the application in one container and then runs it. Builds another container that will run the application. And then your entry point from Jenkins is almost just Docker build. And then do your instrumentation after that for testing and stuff.
Okay. Not something we've kind of done a lot.
I guess you would test to fail early, right? But
Yeah.
the idea is they'll fail because they're part of the container build.
Okay, yeah. One of the things we've done is that the build in our case is actually the last stage, in a sense. It's before it goes up to Kubernetes. It's the stuff after the tests are passed, yeah.
Yes, so you're currently building on a build slave as opposed to inside the container.
Yeah,
in the same environment, but it will ultimately run in.
Yeah, although essentially we are still running it and using Docker Compose in essentially the same kind of container. So it's kind of the same as what you're saying, I think, because we are.
But you're adding a lot of stuff to that container to build it, and then you're not getting rid of it again.
I see what you're saying. So we're adding the dev dependencies, for example,
Yeah.
that we wouldn't do in production. Yeah. Actually, having said that, we're kind of doing it twice. Yeah. So we are running it in with node env equals test, I guess.
Right.
And then the Docker file is then.
So it's currently split up by a script anyway.
Yeah.
That makes sense. It's a bigger issue with some other application runtimes where the build environment is huge, like .NET, and then the actual runtime environment is tiny.
We are moving more towards
running all our tests against our Docker images, and as we're getting more mature with the stack, I think we are trying to get as close to production as possible.
The idea being that it's running in the same runtime as
Yeah.
you're actually
Yeah, so
wanting
there's
to
no
fail in
discrepancy.
the same environment and the same dependencies and the same everything.
Yeah.
It wants to be completely immutable.
Cool. Thanks very much for listening. Thanks.